All right, so our next lesson is about interpreting graphs, and we're going to be working with qualitative graphs. So these are graphs that describe situations. Oh, there we go. So here's our first one. It's a graph, and if we look at the pieces of the graph, we have that our x-axis is talking about time. So as time goes on, we are working only in the first quadrant. And then we have our speed. So this would be a constant speed because it's not changing. So that's the part of the graph that we would consider constant. And then this piece over here, this is what we call an increase. So with each second actually that goes by, that once we start at about this point right here, we start increasing in our speed. So what would be a situation that this graph could be describing? And so a situation this graph could be describing is a skier. So the skier is going, skier goes up a mountain at a steady pace then skis downhill. So the steady pace is meaning that they're going at the same speed all the way up the mountain. And then once they get to the top of the mountain, they ski downhill. Now, I know that in our mind, downhill would mean like all of a sudden we're moving down. But when we think about what the graph is telling us, the graph is telling us about our speed. And as we go downhill, we increase in speed, and that's exactly what's happening. So that's one example of a situation where a qualitative graph, or how a qualitative graph works. All right, so interpreting a graph. So many situations can be interpreted from a graph. So here again, we have time in hours and our temperature. And depending on the time, over here, our temperature is increasing. And sometimes it's increasing faster than others, but it is always getting this increase. At about this point right here, we've reached our high for the day. And then we start at first a slow decrease, but then, some points go faster than others. But we do start to decrease in temperature after that high point. That's how we interpret a graph. We don't have to have the whole story, but it can tell a story. So we could say that this was the temperature after midnight or whatever, or started at like 7 a.m. and then our temperature slowly increases, and that's, like we said, sometimes it increases faster than at other times, and then we hit our high for the day, and then we somewhat stay near that temperature, but then we continue to decrease, and sometimes we make a big dip in that decrease, and sometimes we don't. But that's one way we could interpret this graph. All right, so here is our next one. A jogger begins her run around a park by increasing her speed until she reaches her normal jogging speed. So we're going to start sketching. She then jogs at a constant speed for most of her run. Finally, she begins her cool down by jogging at a slower rate until she stops. So, things to note. She begins her jog by increasing her speed until she reaches her normal speed, and then she does a constant speed for most of her run. finally she begins her cool down by jogging at a slower rate. So I just circled 3 keywords that tells us what we're doing, and we have 3. That means we have 3 different critical points, so points where things change. So at first, she runs around the park by increasing her speed. So she's going to run around the park, increasing her speed. And we're going to start at 0, 0, because you don't randomly start, just we're timing when she's running, so, and her speed. So we've got her until she reaches her normal jogging speed. And then once she reaches that jogging speed, she is constant speed for most of her run. So we're going to call that this most of her run. And then finally she begins her cool down by jogging at a slower rate. So then our speed continues to go down until we get back to 0. And so that is us doing our increasing, our constant, and our slower rate. So that's how we sketch it. All right, so label each interval as increasing, constant, or decreasing. So A, and we're always reading from left to right. Oops. From to right. In case you forgot. All right, so on A, from left to right, we're going down. So A would be a decrease. And looking at interval B, we are staying at 0 that whole time. So that is a constant. C, we are increasing in value as we go from left to right. So that would be an increase. And then D, again, we are staying constant. So that is a constant interval. All right, another example, label the graph to indicate which intervals are increasing, decreasing, or constant. So again, going from left to right. So from left to right, this half is increasing. And I know we want to say, but the arrow's going down, Mrs. Cartwright, but we read from left to right. So from left to right, we are going to increase until we hit what we call the vertex. And then from that vertex, we start our decrease. And so the first half is increasing, the second half is decreasing, and there is no constant. Because once we hit that 0, 0, it starts going the other direction. So, and last one, the graph shows the speed of a commuter boat as it makes an evening trip. Part A, how many constant intervals are defined in the graph? So there's 1, 2, 3, but if you look carefully, 4 and 5. So there are 5 constant intervals, and it asks, how are those constant intervals alike? And they are alike because their speed, or they indicate a constant speed, meaning our speed is not changing. And then it asked, how are they constant intervals different? And so some of the ways they are different is they have different time lengths. Oops. And they happen at different speeds. So we have some speeds at 0, this one's at 20, at 30, and at 25. So we have 5 constant intervals, but they are happening at 4 different speeds. Oh, I misspoke. That was not the last one. Example 4, we're going to match each description with its corresponding graph. So just think of what we have in common. So you leave home and ride your bicycle to the library. So we're leaving. Where you stay for a while doing a research for your project. So here, stay would be a keyword. Then you ride to your friend's house. Ride to friend's house. I didn't mean to draw through it, but so things we need to look at. Our y value is our distance from home. So we are leaving home. That's key. Whereas this first one tells us we are leaving somewhere away from home, right? Because we're home is 0. And so just in that moment and right there, we leave home, we know that our answer is graph B, or the second one, whatever you want to call it. But then when we think about it, we left home, we rode to the library, we stayed at the library doing research, and then we rode to a friend's house. So we can also double check our graph as we go. All right. Here is writing a situation that reflects a given graph. So looking at the graph, we're height from the ground and our time, and we increase, right, in constant and decrease. And so we want to look at things that have that order: increase, constant, decrease. So a jet is coming down from the sky. It reaches a height. So this says coming down from the sky, and we're looking for height. So is our height decreasing in this one? It's not. So I know it's not A. I don't even have to read further. I also like these one sentence ones are easy to read. A jet is going up the whole time. If it was going up the whole time, we'd be increasing the whole time. So it's not D. A jet is flying at the same height the whole time. Well, that would be a constant horizontal line. So it's not C, which means it should be B by order or by process of elimination. A jet is going up in the air. It reaches the necessary height and stays at that height for a period of time. Finally, the jet is coming down. And so that is our increase, constant, decrease written in words. And that's how we use qualitative graphs to represent situations. So until next time, 8th graders, stay classy.